Ever wondered how stars are born, live and die in our galaxy? Our Milky Way is a bustling cosmic city, home to billions of stars. But these stars are not isolated entities. They form intricate families known as stellar clusters and associations. Just like human families, these stellar families share common origins and characteristics. They're born together from the same cosmic nursery, live together, and even drift through space together, bound by the invisible threads of gravity. They are the cosmic laboratories where stars are born, age, and eventually meet their demise. By studying these stellar families, astronomers can peek into the cradle of star formation, observe the various stages of stellar evolution, and ultimately understand the life cycle of stars. So these clusters and associations are more than just pretty constellations in the night sky. Understanding these stellar families is key to unraveling the mysteries of our galaxy. So how do these stellar families form, you may wonder? Well, it all begins with a molecular cloud, a dense and cold region of space where gas and dust are abundant. These clouds, often spanning light years across, are the birthplaces of stars. As these clouds accumulate more and more matter from their surroundings, the cloud's own gravity starts to play a crucial role. The gravitational pull of the cloud causes it to start contracting, a process known as gravitational collapse. This collapse creates denser and denser regions within the cloud, and it is within these dense pockets that stars begin to form. Imagine it like this. The molecules within the cloud are like dancers in an intricate cosmic ballet, swirling and twirling around one another as they're drawn together by the pull of gravity. As the dance speeds up, the region becomes hotter and denser, eventually reaching a point where nuclear fusion can ignite. This ignition marks the birth of a new star. The intense heat and radiation generated by this newborn star can push away the surrounding gas and dust, creating a clear space around the star. And thus, within the dense confines of a molecular cloud, a stellar family is born. This stellar birth is not a solitary event. Hundreds, thousands, even millions of stars can form within a single molecular cloud, creating a bustling stellar nursery. It's a fascinating process of transformation from a gas cloud to a stellar family. Not all stellar families are alike, though. Just as human families can be wildly diverse, so too are the clusters of stars scattered throughout our Milky Way. To start, let's talk about open clusters. These are relatively young, loosely bound families of stars. Born from the same giant molecular cloud, they are held together by the delicate balance of gravitational forces. They're like the rebellious teenagers of the stellar world, often found in the bustling spiral arms of the galaxy, containing anywhere from a few dozen to a few thousand stars. Next up, we have globular clusters. These are the elders of the galaxy, ancient and tightly bound, each containing hundreds of thousands, even millions of stars. Residing in the halo of the galaxy, globular clusters orbit the galactic core like satellites, their densely packed stars creating a spherical shape. Lastly, we have young stellar clusters, the infants of the stellar families. These clusters are hotbeds of star formation, still enveloped in the gas and dust from which they were born. They represent the earliest stages of stellar evolution, providing astronomers with invaluable insights into the birth and early development of stars. Each type of cluster, with its unique characteristics and life stages, offers a different perspective on the life cycle of stars. From the youthful open clusters to the ancient globular clusters and the infant young stellar clusters, these diverse families of stars each have a unique story to tell. There's more to these stellar families than meets the eye. Let's delve into the dynamic universe of stellar associations, a term used for loosely bound groups of young stars that originate from the same molecular cloud. Unlike the tightly knit stellar clusters, these associations are like extended relatives sharing a common origin but drifting casually through the galaxy. These associations are not just drifting aimlessly, however. They're on a mission, playing a vital role in the galactic environment. As these stars drift, their gravitational forces tug and pull on the interstellar medium, the gas and dust between stars, sculpting it into intricate patterns. This stellar choreography sets the stage for future star formation, making these associations essential players in the cosmic cycle of birth and rebirth. But it's not just about star formation. Stellar associations also contribute to the galaxy's evolution. When the most massive stars in an association explode as supernovae, they disperse heavy elements into the interstellar medium, enriching it for the next generation of stars. This process, known as chemical enrichment, is a key factor in the evolution of galaxies. So as we look to the night sky and marvel at the distant constellations, remember the unseen dance of stellar associations. These drifting families of stars aren't just beautiful to behold, they're cosmic architects, sculptors and chemists all rolled into one. These drifting families of stars play a crucial role in shaping our galaxy. But how exactly do stars form within these clusters and associations? Let's delve into the mechanics of star formation, an intriguing process that takes place within the heart of stellar clusters and associations. It's a cosmic symphony of sorts, orchestrated by the universal laws of physics. It all begins with a dense cloud of interstellar gas and dust, referred to as a molecular cloud. Gravity pulls this cloud together, causing it to contract and fragment into smaller, denser regions. Each of these regions or cores has the potential to become a new star. As a core continues to collapse under its own gravity, the center heats up, forming a protostar. This is the first stage in the life of a star. The surrounding material in the core forms a rotating disk around the protostar. This is called a protostellar disk, and it is from this disk that planets may eventually form, but the story doesn't end there. The protostar continues to grow as material from the disk falls onto it, a process known as accretion. As the protostar accretes more and more material, it becomes denser and hotter. Eventually, the temperature and pressure in its core become high enough to ignite nuclear fusion, and a new star is born. However, star formation is not a standalone process. It is regulated by feedback mechanisms. For instance, as a star forms, it emits powerful winds and radiation that can blow away the surrounding gas and dust. This feedback can limit further star formation within the cluster or association. So it's not just about gravity pulling things together. It's also about the energy that the forming star emits, pushing things away. It's a delicate balance, a cosmic dance of sorts. The interplay of gravity, matter and energy in these stellar nurseries leads to the birth of stars, each with their own unique properties and potential planetary systems. It's a complex dance of gravity, matter and energy leading to the birth of stars. So where do these stellar families fit in the grand scheme of our galaxy? Stellar families, each unique and diverse, occupy their own special corners of the Milky Way. From the bustling downtown areas where globular clusters huddle together in their thousands, to the quieter suburban neighborhoods where open clusters and stellar associations take up residence, they are scattered across the galactic plane. These families aren't just randomly sprinkled. Their distribution and spatial arrangement give us clues about the structure and history of our galaxy. Take globular clusters, for instance. These ancient congregations of stars surround the galactic core like a swarm of bees, offering insights into the early formation of the Milky Way. On the other hand, open clusters and associations, often found in the galaxy's spiral arms, give us a glimpse into more recent, ongoing star formation activity. These stellar families are integral pieces of the cosmic puzzle that is the Milky Way. Our journey through stellar families brings us to the end, but the exploration doesn't stop here. As we've seen, these celestial communities, from the tightly bound globular clusters to the more loosely associated stellar groupings, all play a crucial role in the cosmic narrative of our galaxy. These stellar families are not just beautiful to behold, but serve as cosmic laboratories, enabling us to probe into the mysteries of star formation and evolution. Each cluster, each association is a testament to the diversity and complexity of processes that shape the Milky Way. Just as a family tree can reveal much about our personal histories, these stellar families provide key insights into the life story of our galaxy. They remind us of the interconnectedness of all cosmic entities and fuel our ongoing quest to understand the universe. As we gaze at the stars, we're looking at the rich tapestry of stellar families that make up our galaxy, each with their unique cosmic tale to tell.